Hello everyone and welcome back. Today we're going to be making this. This is the XY joiner plate for my Milo 1.5 and I'm going to be taking you through a trip of, how I made this on my Milo. So as you might know, currently all my XY joiner plate and the Z plate are still in their printed form, and I'm upgrading them slowly to become the milled version in order to improve rigidity. As you can see, or maybe if you know the design of Milo, this is pretty much the standard XY joiner plate, except for these two holes over here, this one and this one. These two holes are there for me to do some aligning, and you'll see them later as 6mm fixture pins, which will be used to align the plate on my fixture plate. So, what are we going to do? First of all, we're going to start with my stock. My stock size in this case is 165 by 130 by 12mm. As it turns out, my plate is actually a bit larger than this, 12.45 or something like that millimeters. So that's gonna be a slight adjustment I'll have to make later. But yeah. So in the first setup, we are going to only do some very minor stuff. First of all is going to be a boring operation in order to create the location holes and some holes which we are going to use to fixture the plate on the part on the fixture plate later. And this is done while fixturing the XY joiner plate onto the fixture plate only with double-sided tape. I'll give you a shot of that, but in short, it's boring holes. We've seen that in the last video. Now for the second op, we're gonna do some facing. This is once again my 35mm insert 3-flute face mill, and we're gonna spin it at 18,000 RPM. That's the lowest I can go, and in order to get some sensible feed per tooth, we're gonna run it quite fast. This is 810mm per minute. And we're gonna take two step-down roughing passes of 0.4mm and then a finishing step down of 0.2 millimeters. Let's cut to that. So now we come to my first, in air quotes, real operation. As you can see, I have now done the few board holes you can see, and I face the top. And now my origin I've set to this dowel pin location up here at the top. If you are very close with your observation, you will see that my origin is at the bottom of the hole, and that is going to create some problems for me in just a bit. Mainly that all my board features are going to be about 1.4 millimeters too deep, because I didn't check that prior. And in doing so, I probed all my tools against my fixture plate, and thus everything here is about 1.4 millimeters too deep. But it should work out in the end, and we'll just keep going with that. So the first operation is just a bore. I'm using the 6mm stubby, the 12mm cutting length, and 24,000 RPM at 500 millimeters a minute. And we're doing a 2-degree ramp, and we are boring out all the features that are needed for the carriage mounting and the lead screw mounting here first. So let's do that. Now my next two operations are a 2D adaptive and a 2D contour to establish the outside contour of the part. Both of these are also done with the 6mm stubby 12mm flute length. Once again, 24,000 RPMs, 500mm a minute, a optimal load of 1.2, and some radial stock to leave in the adaptive in order to clean that up with the contour pass. And the contour pass is basically doing the same. 24,000 RPM, 500mm a minute, no stock to leave, and doing a repeat finishing pass. So let's show you that. Alright, so that leaves me only with the last operation, which is chamfering. Well, chamfering is a bit sensitive to, is very sensitive to correct Z height. So in this case, my chamfers are going to be quite a bit wider than they're supposed to be because of that issue I've mentioned earlier with my incorrectly set Z0. But I'm gonna run, this is the 10mm 45 degree or 90 degree included angle. Chamfering bit from the Drenic starter kit for Milo. Once again, 24,000 RPMs, 1,000 millimeters per minute on this one because it's a 2-flute. And, well, everything in here should be as you would expect. But once again, these chamfers are going to be wide, and well, it works, but it isn't perfect. So let's cut to that. So now that the first side is done, we can flip the part over. And as you can see, I'm using this front dowel pinhole for XY alignment. and this time using the Z bottom as the Z0 height is correct, and this gives me great control over the correct height of those parts. And yeah, so first of all, we're gonna get rid of this top hat that I've left on the previous part. It's gonna be just a simple contour to get moving around the perimeter and move that out of the way. So let's do that. So now that the top head side parts are out of the way, we can do the boring. This is once again the same procedure as we did in setup 1, just on the other side this time. Once again, the 12mm long 6mm diameter stubby, 500mm a minute, 24,000 RPM, everything's the same as before, so let's do that. So as you might have noticed, this operation was done while holding the part via these two holes here with a bolt. But for the next operation, for the facing operation, we need to have complete access to the top face. And this is why I'm doing the boring first. And now we can mount the part completely with these 3 bolts in these recessed holes. And we get access to our facing operation. This, once again, is basically the same thing we did on the other side, except for this time we have to do a few more passes. I'm just going to speed through this, and this is the same as we saw before. So let's do that. And now for the last operation, this is chamfering, and this time you're going to see this is going to go well. No problems here. The clearance on these recessed bolts is tight, but it works. So let's show that. So this is the final part. I'm going to show you both sides, of course. On the first pick, you can see the Y chamfers we did with the incorrect Z height. So this is definitely a lessons learned for the next time. Correct the Z height, or to be honest, for the op1, the first side operation, just use the Z0 as the top of the part, which is a surface we just surfaced, so why not use that? That's going to be a change definitely for any future operations or future times I'll make this part. So I'm gonna show you what I did and what I did wrong, and so yeah. Also check out the surface finish. I think that's pretty nice. This is still not the top thing that I can probably achieve with this 3-flute face move, but I like it. So yeah, let's see how it goes. I hope you enjoyed this video. I hope I see you in the next one, and yeah, goodbye until then.